The next chapter, interference and diffraction of light. So, in Young's double slit experiment, the ratio of intensity of bright and dark bands is 16, which means options are the ratio of their amplitude is 5, the intensities of individual sources are 25 and 9 units respectively. The ratio of the amplitude is 4. Intensities of individual sources are 4 and 3 units respectively. Okay, first of all we can write I1 upon I2 is given as 16, but I is directly proportional to A square. So I can say I1 upon I2 is equals to A1 upon A2 the whole square. Therefore A1 upon A2 is equals to under root of I1 upon I2, that is equals to under root of 1 upon 16, that is 1 upon 4. Now I max is given as A1 plus A2 the whole square, and I minimum is A1 minus A2 the whole square. So this is 4 plus 1 the whole square upon 4 minus 1 the whole square, since A1 is 4 and A2 is A1 is 1 and A2 is 4. So therefore we get 5 the whole square upon 3 the whole square, which is 25 upon 9. So I can say intensities of individual sources are 25 and 9 units respectively. Option Bombay. Now the next question is, in Young's double slit experiment, the fringe width is found to be 0.4 mm. If the whole apparatus is immersed in water or refractive index 4 by 3 without disturbing the geometrical arrangement, the new fringe width will be. Now, fringe width beta is lambda d upon d. Therefore, from here beta is directly proportional to lambda. Therefore, beta 2 upon beta 1 is equals to lambda 2 upon lambda 1. Therefore, beta 2 is equals to beta 1 into lambda 2 upon lambda 1. So this gives me 0.4 upon 4 by 3. So this is equals to 0.4 into 3 upon 4, which is 0.3 mm. So the new fringe width will be 0.30 mm. Option A. The next question, in the Young's double slit experiment, using a monochromatic light of wavelength lambda, the path difference in terms of an integer n corresponding to any point having half the peak intensity is. Alright, so we can say I is equals to I max cos square phi by 2. So therefore you can say cos square phi upon 2 is equals to I upon I max. So that is 1 by 2. So cos square phi by 2 is 1 by 2. Therefore cos square phi is equals to 0. So therefore phi can be pi by 2, 3 pi by 2, 5 pi by 2, either. So therefore the corresponding path difference can be written as delta x is equals to lambda by 4 comma 3 lambda by 4 comma 4 lambda by 4. So we can say that delta x is equals to 5 lambda by 4, delta x is equals to 2n plus 1 lambda by 4. 2n plus 1 lambda by 4, option is B. The next question: which one of the following is used to eliminate headlight glare in automobiles? So only a Polaroid can be used to remove glare, hence option A. So the next chapter is electrons and photons. Find the de Broglie wavelength of an electron with kinetic energy of 120 electron volts. So you can say E is equals to 120 electron volts, that is 120 1.6 into 10 raised to minus 90, and this gets converted into joule. So 120 into 1.6 is 1.92 into 10 raised to minus 17 joule. Alright, de Broglie wavelength lambda is equals to h upon under root of 2e. So this is 6.63 into 10 raised to minus 34 upon under root of 2 into 9.1 into 10 raised to minus 31 into 1.92 to 10 raised to minus 17, the whole inside root. This is 6.63 into 10 raised to minus 34 upon 2 into 9.1 is to the 18. So 18.2 into 1.92 into 10 raised to minus 31 minus 70, 10 raised to minus 48, and it will come outside as 10 raised to minus 24. So this will go as 6.63 to 10 raised to minus 34 upon under root of, we'll take 18.2 as 18 and 1.92 as 2, and this will become 10 raised to plus 24. So 2 18s are 36. So it is root 36, that is 6.63 upon 6 into 10 raised to minus 10. So this will give me 0.11 0 10 raised to minus 12, that means 11 or 1110 point, also 110 into 10 raised to minus 12, which is 110 picometers. So 110 picometers is close to 112 picometers, hence option A. The next question: if an electron has energy such that its de Broglie wavelength is 5500 angstrom unit, so lambda has been given as 5500 angstrom unit, that is 5500 into 10 raised to minus 10 meters, then the energy value of that electron E has been demanded. H is given as 6.6 into 10 raised to minus 34 joules second, and the mass of electron has been given as 9.1 into 10 raised to minus 31 kg. We have the formula as lambda is equals to H upon P, and they have asked an energy value. That means kinetic energy is given as P square upon 2m. Therefore P is equals to H upon lambda. Therefore this becomes H square upon 2m lambda square, that is 6.6 to 10 raised to minus 34 the whole square upon 2 into mass of electron is 9.1 into 10 raised to minus 31 into 5.5 into 10 raised to minus 7, that is 5500 into 10 raised to minus 10 the whole square. This will give me the answer very close to 7.91 into 10 raised to 20 minus 25. It is almost 8 into 10 raised to minus 25 joule. So this is 8 into 10 raised to minus 25 joule. Option D. Now, when a monochromatic light of wavelength lambda is incident on a metallic surface of stopping potential for photoelectric current is plus 3 volt V naught. When same surface is illuminated with light of wavelength 2 lambda, the stopping potential is now B naught. The threshold frequency or the threshold wavelength for this surface when photoelectric effect takes place. Okay, so we can see first of all what is the photoelectric equation. So photoelectric equation has been given as Hc by lambda is equals to Hc by lambda naught plus 3V naught. Therefore Hc by lambda is Hc by lambda naught. In the first condition this is lambda 1 and this is lambda 2, so I'll keep it this as lambda, but this will become 2 lambda plus, and 3V naught will be replaced by V naught. So subtracting 2 from 1, this is subtracting 2 from 1, I'll get Hc by 2 lambda minus Hc by lambda is equals to Hc by lambda will get cancelled. This will become 3 V naught minus V naught, which is 2 V naught, and this is Hc by lambda minus Hc by 2 lambda. So I get Hc as common, and simplified answer will be V naught is equals to Hc upon 4 lambda. So I got the value of V naught. I can substitute in either of the equation, and substituting this V naught in equation number 2, because I did not have to multiply it with 3. So I can say Hc by 2 lambda is equal to Hc by lambda naught plus Hc by 4 lambda. So Hc will get cancelled. I'll take 1 upon 2 lambda minus 1 upon 4 lambda is equals to 1 upon lambda naught. So therefore this becomes 4 minus 2 is 2 upon 8 lambda, it is 1 by 4 lambda equals to lambda naught. Therefore lambda naught is 4 into lambda. Option D. The next question, a particle is dropped from a height h. The de Broglie wavelength of the particle as a function of height is proportional to. So we want de Broglie wavelength and the relation between h. So we can say lambda is given as h upon mv. Now if the particle is dropped from a height, I can say its velocity is given as freely falling body under root of 2gh. Therefore I can substitute the velocity of as a value of velocity in equation 1 will become h m under root of 2gh. So this is h upon m into root 2g into root h. We can say h upon m root 2g entirely is a constant, because mass of electron is a constant, Planck's is constant, g itself is a constant. Therefore lambda is inversely proportional to under root of h. The lambda is proportional to h the whole raised to minus half. Option D. The next chapter is atoms, molecules and nuclei. The first question, in an atom, 2 electrons move round the nucleus in a circular orbit of radii r and 4r. the ratio of the time taken by them to complete one revolution. Okay, so we need relation between r, velocity, and number of revolutions over here. So r, v, n, and also time period. We all know that r is directly proportional to n square and v is inversely proportional to n. T is equals to 2 pi r upon v. Therefore T is proportional to r by v. So if I substitute r as n square and v as 1 upon n, this is T proportional to n cube. So therefore r1 upon r2 is equals to n1 upon n2 the whole square. So therefore r1 upon r2 is equals to r upon 4r, that is equals to n1 by n2 is equals to half. Also t1 by t2 is equals to n1 cube upon 2n1 the whole cube. So this becomes 1 by 8. Answer is option B. The next question, minimum energy required to excite a hydrogen atom from its ground state is. So minimum energy E minimum is equals to 13.6 into 1 upon V square minus 1 upon N square. That is 13.6, that is ground state is 1 square minus half square, that is equals to 13.6 into 1 minus 1 by 4, that is 13.6 upon 4 into 3, so this is 10.2 electron volts. Option D. The next question, the ionization energy of hydrogen is 13.6 electron volts. The energy of the photon released when an electron jumps from the first excited state n equals to 2 to the ground state of the hydrogen atom. Okay, so now the energy will be released, so therefore ground state energy level minus 13.6 electron volts, that is equals to E1. So for En is equals to minus 13.6 upon n square. Therefore if it is E2, I would say minus 13.6 upon 2 square, so which is 13.6 or minus 13.6 upon 4, this is 3.4 electron volts. Therefore energy released will be minus 3.4 minus 13.6, just minus 3.4 plus 13.6, which is 10.2 electron volts. Option C. Now the next question is, if an electron in a hydrogen atom jumps from an orbit of level n equals to 3 to an orbit of level n equals to 2, the emitted radiation has a frequency. So frequency has been demanded. We all know that 1 by lambda is equals to r into 1 upon n1 square minus 1 upon n2 square. This can be given as 1 upon lambda is equals to r into, so from 3 2, so n1 is 2 square minus n2 is 3 square. Lambda can be given as nu is equals to c upon lambda. So therefore lambda is equals to, or nu is equals to c upon lambda, so I can say that c upon lambda will be substituted as 1 upon lambda is equals to r into 1 upon 4 minus 1 upon 9. This gives me 5 by 36 r. So nu becomes rc to 5 by 36. So 5 by 36 rc, option C. Next question. R1 and R2 are the radii of atomic nuclei of mass number 64 and 27 respectively, the ratio of R1 and R2. Now we know that R1 upon R2 is equals to A1 by A2, the whole raised to 1 by 3, since R is directly proportional to A raised to 1 by 3. So therefore R1 by R2 is 64 by 27 whole raised to 1 by 3, that is equals to 4 by 3, option C. Current electricity synopsis. We are going to discuss first of all important formulas. Okay, E is equals to V plus IR, ES is equals to NE, that is equivalent EMF in series combination, and this was EMF of a cell. Okay, if total current through the series combination of n cells, so total current in series combination is given as NE upon R plus NR. Total current in series combination. Now also for parallel we'll do NE upon NR plus R. Now for parallel combination, we have Kirchhoff's first law. Kirchhoff's first law is given as summation of current is equals to 0, that is I1 plus I2 plus I3 is equals to 0. Also Kirchhoff's second law, we have summation of delta V, that is the voltage equals to 0, that is I1 R1 plus I2 R2 plus I3 R3 is equals to E1 plus E2 plus E3. We have Wheatstone's bridge, that is P upon Q is equals to R upon S. The next is unknown resistance in meter bridge. So meter bridge, unknown resistance, the formula will be S is equals to 100 minus L upon L into R. Then we have comparison for two unknown resistance. So comparison for two unknown resistance. So we can say R1 by R2 is equals to L2 by L1 into 100 minus L1 upon 100 minus L2. Now unknown temperature in meter bridge. Now, this is an important formula. Unknown temperature meter bridge. So we have T degree Celsius is equals to R minus R naught upon R 100 minus R naught into 100. Then we have principle of potentiometer. V is equals to X into L. Then we have balancing condition. For potentiometer, V is equals to E and E is equals to XL. Comparison of EMFs. E1 upon E2 is equals to L1 upon L2. So these were the formulas. Now certain synopsis and shortcuts. Safe current for the fuse wires relate with its radius as I is directly proportional to R raised to 3 by 2. Next, in a potentiometer, if V is constant, then we can say L is directly proportional to small l, that is x1 upon x2 is equals to L1 upon L2 is equals to L1 upon L2. Next, after stretching, if length of a conductor, see these questions come after stretching, if the length of the conductor increases by x%, then resistance increases by 2x%. But there's a condition, it is valid up to x less than 10%. You see, we can straight away say it is 2x%. We do not need to solve it. Hence this is a shortcut, but only valid when x is less than 10%. Okay. The next is, if we are using n conductors of equal resistance, the number of possible combinations, the number of possible combinations is 2 raised to n minus 1. If the resistance of n conductors are totally different, then the number of possible combinations will be 2 raised to n minus 1. If an identical resistance or resistances are first connected in series and then in parallel the ratio of the equivalent resistance. The ratio of the equivalent resistance is given by Rp by Rs is equals to N square upon 1, or Rp by Rs is equals to N square. So that's all with current electricity. Now the next chapter is magnetic effect of electric current. We'll discuss the formulas first. Important formulas. Basically we'll start with magnetic flux, which is a scalar quantity as in given as BA cos theta. Next is Biot-Savart's law. Although it's a part of standard 11th, but it has importance in standard 12th. Biot-Savart's law, we all know this law as dB is equals to mu naught upon 4 pi dl sine theta upon r square. Now the next is Ampere's circuital law. Ampere's circuital law, we can say line integral of B bar dot dl bar is equals to mu naught times I. B due to infinitely long straight wire carrying conductor. Okay, it is given as B is equals to mu naught upon 4 pi I upon R sine phi 1 plus sine phi 2. Infinitely long straight conductor. Next is magnetic induction that is B due to long or due to a toroid, that is B equals to mu naught Ni. It is also known as Rowland's ring. Next is force on a charge. And this is again from standard 11th in uniform magnetic field of induction, which is given as F is equals to QVB sine theta. Now we also have another force called as Lorentz force, and this equation is given as QE bar plus Q B bar cross B bar. The next formula is frequency of an electron, or specifically a charged particle, not electron, charged particle in a cyclotron. So it is given as nu is equals to Q B upon 2 pi m. Now kinetic energy attained by the particle, now that is given as kinetic energy is equals to Q square P square R square upon 2m. Now this is nothing but maximum kinetic energy, which can also be given as QE. Okay. The next is torque acting on an MCG. So we have one deflecting torque called as NDIA, and we have one restoring torque which is K alpha, which is also known as C theta in the government textbook. Now, I is given as K upon NAB into alpha. Therefore, I is equals to K alpha, where K is K upon NAB. I would replace K as K dash so that this becomes simpler. Now, sensitivity of MCG, which is moving coil galvanometer, the sensitivity SI is equals to theta upon I, which is NAB on K. Then we have voltage sensitivity. Voltage sensitivity denoted as SV. Now this is current sensitivity, this is voltage sensitivity, and it is given as theta upon V, which is NAB upon kg, where G is galvanometer resistance. This is SI upon G because the entire term is SI. Alright. So next is accuracy of MCG. So accuracy of MCG, I upon DI is equal to theta upon d theta. Now this is given as DI is equals to K d theta upon NAB. The next is percentage error in a measurement of current, or in measurement of current is given as di upon I into 100. Now ammeter, there is one simple formula, ISS is equals to Ig into G. Also Ig upon I is equals to S upon S plus G. This is also equivalent to S is equals to Gig upon I minus Ig. Then we have voltmeter. Voltmeter, we have R is equals to V upon Ig minus G. If V is equals to NVG, we can say that R is equals to G into N minus 1. Ig can also be given as V upon R plus G. So that's all with the formulas. I will deal in shortcuts and synopsis. Now, if in the question two values of current is given, we can use, or we can say, the smaller value as Ig and the bigger value as I. So basically, if the value is in milliamperes, straight away we can say that is the current passing through the galvanometer, and if the value is in amperes, we can say that is total current I. Okay. If in the question only one value of current is given, it will always be Ig. Value of current is given, it will always be Ig. Now we have a formula stating that R is equals to V upon Ig minus G. Here V is the new range of voltage it is required. For a voltmeter, value of R should always be very high. And value of S should be very small. Alright. Now, in order to reduce the range of voltmeter of resistance G from V to V upon N. Now we are going to decrease or reduce the range of voltmeter from V to V by N. A shunt equal to Ng. A shunt equal to Ng should be connected in parallel. Magnetism important formula is we can say M for a revolving electron is given as M is equals to N into EH upon 4 pi M. Next is magnetic induction can be given as B bar is equals to F bar upon N. Next is time period of a R magnet. This is a very important formula. T is equals to 2 pi under root of I upon MB. Then magnetic potential. Now this is given as V is equals to mu naught upon 4 pi R2 minus R1 upon R1 R2. If dipole is very short, that is short magnetic dipole, we can say V is given as mu naught upon 4 pi M cos theta upon R square. We have V actual is given as plus or minus mu naught upon 4 pi M by R square, where theta is 0 in the above formula. And we have V equatorial. So V equatorial will straight away be given as 0 because theta is 90 degree. So we get the answer as cos 90, and cos 90 stands 0. Now, so magnetic induction at any point due to short magnetic dipole is given as, so B at any point due to a short magnetic dipole. The formula can be B is equals to mu naught upon 4 pi, this is the permeability constant, M by R cube under root of 3 cos square theta plus 1 at any point. Okay. We have angle of dip from standard 11th. It is given as delta is equals to BV upon BH. Now, there is a horizontal component which is known as PH, it is the Earth's magnetic field horizontal component, given as B cos delta, and a vertical component is given as B sin delta. We are familiar to these formulas. Alright. Then we can write neutral point lie on axial line of magnet. So neutral points lie on axial line of magnet. So we want magnetic induction, so it can be given as B equals to, or B is equals to mu naught upon 4 pi 2 md upon d square minus L square the whole square, which is also given as pH. Now, same neutral points lying on equatorial line of magnet. So we want BH now, and this is B2 is equals to mu naught upon 4 pi m upon d square plus L square the whole raised to 3 by 2. This we have seen in the chapter magnetic effect of electric current, also in the standard in the chapter magnetism. Okay, so now we have the main formulas of standard 12th. First of all, magnetization, which is being given as mz is equals to net magnetic dipole moment per unit volume. So the next formula is intensity, that is magnetic intensity H is equals to Ni, is also B naught is equals to mu naught H, therefore H is equals to B naught upon mu naught. Okay. The next is relative permeability, which is given as mu r upon r is equals to mu upon mu naught. Permeability mu is given as B by H. We have susceptibility, which is I upon H, also mz upon H. Okay. I is intensity of magnetization. The same. Okay. Curie's law. So Curie's law, susceptibility is equals to C by T. Also B, or magnetic induction, is given as mu naught H plus mz or mu naught H plus I, where I stands for mz. So these are the important formulas from chapter magnetism. Now we will see the synopsis. Shortcuts. Cutting a bar magnet into equal pieces along its length produces magnets of half Volt's length. And also half dipole moment. Alright. The force between two magnetic dipoles, the force between two magnetic dipoles in the end-on position will be given as F is equals to mu naught upon 4 pi 6 m1 m2 upon r is to 4. Now this is very important. The direction of magnetic moment, that is magnetic dipole moment, is always from south to north. South to north. Again I am highlighting, from south to north, opposite of magnetic lines of forces. Value of V on the equator will be always 0. We have calculated this in the formula. Now for a diamagnetic substance, for diamagnetic substances, B will be less than H. Therefore, mu will be less than 1. Now, for diamagnetic substances, susceptibility is between -1 and 0. Next, substance for which mu is highly positive or in the order 10⁴ will always be ferromagnetic. Now if the body is paramagnetic, B will be slightly greater than S. Not much, slightly greater than H. Therefore, mu will be slightly greater than 1. Also susceptibility for paramagnetic. So for paramagnetic substances, we have susceptibility between 0 and 1. That is slightly, the mu will be slightly greater than 1 and susceptibility will be slightly greater than 0 and will be positive. That means small and positive. Alright. The next chapter is interference and diffraction. First of all, the important formulas. Path difference of YDSE. Yes, Young's double slit experiment. Path difference in Young's double slit experiment. X is equals to YD upon D, that is equals to 2n lambda by 2, that is equals to n lambda. The next formula, this is first one, this is second one. Path difference for dark fringes. Now this was for bright fringe, and now this is for dark fringe. X is equals to 2n plus 1 lambda by 2. Distance of nth bright fringe from center. This is given as yn is equals to n lambda d upon d is equals to n beta. Next is fringe width, VIDTH. Fringe width is given as beta is equals to lambda d upon d. Number of fringes is n is equals to width of fringe or width of region upon fringe. Okay, the fringe width, which is equals to L upon beta, width of the region upon fringe width. The next is displacement of fringes. Displacement of fringes may be given as number 1, S is equals to d u minus 1t upon d. This can be replaced as beta mu minus 1t upon lambda. And the next is the number of fringes shifted. The number of fringes shifted. So n is equals to u minus 1t by lambda. So these are all the formulas. Okay, and we have some formulas on intensity. So that is I average is equals to I max plus I minimum upon 2. Now we'll deal in shortcuts here. We can say that when a bichromatic light, alright, bichromatic light is used, then the fringes of two wavelengths will coincide first time when. So when a bichromatic light is used, then the fringes of two wavelengths will coincide first time when y is equals to n beta, that is the longer, is equals to n plus 1 beta for the shorter, or n lambda for longer and n plus 1 lambda for shorter. Now you can say V1 by Vd is equals to lambda 1 upon lambda d, that is equals to beta upon beta d, that is interference pattern is shifted in denser medium. Denser medium. Alright. Now fringe visibility, that is V is equals to I max minus I minimum upon I max plus I minimum. That is given as 2 under root of I1 I2 upon I1 plus I2. Now, for two coherent sources, we have I max is equals to bracket under root of I1 plus under root of I2 the whole square. So root of I1 plus root of I2 the whole square. It is maximum intensity, and for minimum intensity the same formula with a negative sign. Okay, now on immersing apparatus in liquid. So on immersing apparatus in liquid with refractive index mu. So fringe width decreases. Fringe width decreases to beta dash. That will be given as beta dash is equals to beta by mu. So these are the shortcuts for the chapter indifference, and we'll deal in diffraction in the later part. So diffraction now. The first important formula is straight away we can say angular position of nth minimum intensity. Angular position of nth minimum intensity. This can be given as in diffraction. Okay, in diffraction due to a single slit. So theta n is equals to n lambda upon a, where n is equals to 1, 2, 3 and so on. Say if it is first minimum, so first minimum theta 1 lambda upon a, and second will be 2 lambda upon a and so on. Now diffraction due to a single slit of nth minima. So from central maxima which is xn, we get xn is equals to n lambda d upon a, and n is equals to 1, 2, 3 and so on. First minima x1 is equals to lambda d upon a, so the next will be 2 lambda d upon a and so on. Now linear width of central maximum, that is 2x is equals to 2 lambda d upon a, that is equals to 2. That is width of secondary maximum. Secondary maximum. The next is angular width of central maximum, 2 theta. So 2 theta is given as 2f lambda upon a. F, we all know it is the focal length of convex lens. Now, the important formula is on resolving power. So resolving power of microscope, we have 1 upon d is equals to 2 mu sin alpha by lambda, that is directly proportional to numerical aperture, that is inversely proportional to lambda. Now for circular aperture in a telescope. We have resolving power is equals to 1 upon d theta, that is equals to d upon 1.22 lambda. And for rectangular aperture, we can say resolving power is equals to d upon lambda. Malus law, I is equals to I naught cos square theta, where I naught is also equals to k a square. I naught of light, I naught is intensity of light emerging from polarizer. Intensity of light emerging from polarizer. Theta is the angle between axis of polarizer and analyzer. Theta is the angle between axis of polarizer and analyzer. The last is Brewster's law. Mu is equals to tan IP, and IP plus R is equals to 90 degree. So these are the important formulas from the chapter diffraction. Now we'll deal in some of the synopsis and shortcuts. Shortcuts. If lens L2 with focal length F is held very close to the slit, then F can be equal to D. Now, for a microscope, RP increases with increase in the wavelength used. For a microscope, RP increases with decrease in the wavelength of light used. So for violet light, resolving power is more than all colors. Now this is by nature because violet has the least wavelength. Second will be UV light is used for greater RP than visible light. UV light is used for greater RP than visible light. So that's all from chapter diffraction. The next chapter is semiconductors and electronic devices, also known as electronic devices. Number 1, full wave rectifier. We have IDC is equals to 2I naught upon pi, and VDC is equals to 2V naught upon pi. The next formula is peak loaded current, that is I naught, that is peak loaded current. Now this is given as V naught upon RD plus RL. Next is ripple factor, that is given as R is equals to under root of IRMS upon IDC the whole square minus 1, the whole inside the root. Next is Zener diode. So voltage of Zener diode is given as V input minus IS into RS. The next is current is given as IS minus IL. Wavelength lambda is equals to C by V, that is equals to HC upon EG. The next is current through emitter. That is I is equals to IB plus IC. The next is common emitter amplifier. Common emitter amplifier current gain, that is AI, is equals to beta is equals to IC upon IB greater than 1, and we can say beta is HFE. Now we can say voltage gain, we did with current gain, voltage gain, AV is equals to beta RL upon RI greater than 1. Then we have phase shift, that is 180 degree or pi radians. Relation between current and gains. For current and gains are given as beta is alpha upon 1 minus alpha, and alpha can also be given as beta upon 1 plus beta. So AC and DC current gains. So alpha AC is equals to delta IC upon delta IE when VBE is equals to constant. This is important. The next is beta AC is equals to delta IC upon delta IB when VCE is equals to constant. Third is alpha DC IC upon IE and beta DC is equals to IC upon IB. We are familiar with these formulas in the chapter semiconductors. Okay. Input and output voltages for switching circuit. So input and output voltages for switching circuits. VI is equals to VBB, that is equals to IB RB plus VBE. Also VO is equals to VCE is equals to VCC minus IC RC. So these are the important formulas. Now we'll deal in the synopsis and shortcuts. Number 1. In a doped semiconductor, the density of electrons and holes is not equal. It can be shown as Ne into NH is equals to Ni square. This could be in the options, so you can straight away select this. The condition to convert an amplified signal, so amplified signal into an oscillating signal. So we have two signal oscillating and amplified, and we need a conversion factor. So we'll say it is given as beta AV is equals to, that is A suffix V plus 1. Next, if both inputs of NAND gates are shorted, then it becomes NOT gate. If both inputs of NAND gates are shorted, then it becomes your NOT gate. It will be given as like that. So that's all from semiconductors. It's called as NOT gate. Important formulas and synopsis. In the next chapter, atoms, molecules and nuclei. Important formulas. Now, linear momentum of electron. This is given as Pn is equals to me square upon 2 epsilon naught h 1 upon n. Wave number, that is nu bar, is equals to 1 upon lambda, that is E upon hc. Then kinetic energy of an electron. This is kinetic energy is equals to E square upon 8 pi epsilon naught r, that is me raised to 4 upon 8 epsilon naught square h square n square. Then potential energy is minus E square upon 4 pi epsilon naught r or minus me raised to 4 upon 4 epsilon naught square h square n square. Then lastly, binding energy, which is E square upon 8 pi epsilon naught r is equals to me raised to 4 upon 8 epsilon naught square n square h square. The next is relation between energy and Rydberg's constant En and R. So we have En is equals to Rhc upon n square. So next formula is ionization energy. So ionization energy is Ei is equals to on n square electron volts. Excitation energy, that is E is equals to minus of R 1 upon nf square minus 1 upon ni square, that is final and initial, z square ch. Now, number of radioactive nuclei present at time t. Number of radioactive nuclei present at time t. It's given as n is equals to n naught e raised to minus lambda t. Number of spectral lines. This may be given as Na is equals to n2 minus n1 plus 1 into n2 minus n1 upon 2. Also Na is equals to n into n minus 1 upon 2 for n1 is equals to 1. we have half-life period T is equals to ln 2 by lambda, that is 0.693 by lambda. Then we have average life period, it's 1 by lambda. Mass energy relation, we all know this equation, mass energy relation, E is equals to mc square. The next is mass defect, that is delta m is equals to zmt plus a minus z mn the whole minus m, and the last is binding energy, that is equals to delta m c square. So these are the important formulas, and the last formula is binding energy per nucleon. So binding energy per nucleon, that will be given as delta m into 931 upon A. Now we'll deal in the shortcuts and synopsis. Shortcuts and synopsis. First statement: a neutrino is chargeless, has negligible mass, and has a spin half. The decay of artificial radioactive isotopes is accompanied by positron decay. The percentage of mass which changes into energy during fission is of the order of 0.7%. In the fission of uranium, the percentage of mass converted into energy is of the order 0.1%. Angular frequency, that is omega, of electron in nth orbit. So omega n is directly proportional to z square m upon n cube, that is inversely proportional to n cube for hydrogen atom. So that's all with synopsis and shortcuts of atomic molecules and nuclei. The next chapter, wave theory of light or wave optics, important formulas. So we have discussed this chapter as important one. Here we will discuss more shortcuts and more important formulas. Now we have number of waves, which is given as thickness wavelength, that is d by lambda. ratio of width of wavefronts. And refracted wavefront. W1 upon W2 is equals to cos I upon cos R, that is equals to 1 upon mu1 2. This is it, guys. If we draw wavefront, and if this is the refracted wavefront, the width of this is Wi and W, that is W1 and W2. So W1 upon W2 is equals to cos I upon cos R. So this is I and this is R. Doppler effect in light. You can say lambda is equals to lambda naught 1 minus V by C upon 1 plus V by C. Also delta nu upon mu naught is equals to plus or minus V by C, and delta nu upon mu naught is equals to minus of delta lambda upon lambda naught. Therefore delta lambda upon lambda naught is equals to minus plus V by C. So these are the important formulas in the chapter wave theory of light. Now shortcuts and synopsis. According to Voigt and Kirchhoff, the amplitude of secondary wavelet making an angle theta with the normal to wavelet is proportional to half 1 plus cos theta. So according to Voigt and Kirchhoff, the amplitude of secondary wavelet making an angle theta with the normal to the wavelet is proportional to half 1 plus cos theta. So this is the point source, and here it's the secondary wavelet, and if this is the normal, this is the angle theta. So here the amplitude will be given as half 1 plus cos theta. Second, when the deflected rays and refracted rays are perpendicular to each other, we can say I plus R is equals to 90 degrees. The deviation in refraction will be I minus R or R minus I, depending upon which angle is greater. We have the refractive index depends upon 1. Nature of two media, then color of light, that means mu is inversely proportional to lambda, temperature of the two medium, that is mu inversely proportional to temperature, and the fourth is speed of light. Nice. Mu is inversely proportional to c. So that's all the shortcuts of wave theory of light. MCQs on physics part 1, chapter surface tension. Let us see the first question. A liquid is contained in a vertical tube of semicircular cross section as shown in the figure. If the angle of contact is 0, then the ratio of the force of surface tension on flat side to the current side of the tube will be. Okay, so ratio of surface tension on the flat side and the curved side. Now this is also curved surface, and the front surface is the flat surface. So I can say flat plate will have length that is equals to 2r. This is r and this is r, so the length is 2r, while the semicircular plate, the length is equals to pi r, that is half of 2 pi r. Now force is equals to tension into length. The force on flat side will be equals to tension into 2r, and force on curved side will be equals to tension into pi r. So therefore f of flat upon f of curve is equals to t into 2r upon t into pi r. R and R will cancel, t and t will get cancelled, 2 upon pi is the answer. Option D. Now, the angle of contact between glass and mercury, it is 135 degree. Pressure inside two soap bubbles are 1.01 and 1.02 atmosphere respectively. Ratio of their volumes has been demanded. Now, P1 is equals to 1.01. That is P0 plus 40 upon A. Also P2 is equals to 1.02. That is equals to P0 plus 40 by P. P0 is nothing but 1 atmosphere, because it is atmospheric pressure. I can say 40 upon A is equals to 0.01, and 40 upon B is equals to 0.02. So on dividing, I'll say A upon B is equals to 2. This both will cancel out, and 0.01 upon 0.02 upon 0.01 will give me 2. Now we all know that V is directly proportional to A cube, isn't it? A is nothing but radius. So therefore V1 upon V2 is equals to A cube upon B cube. Well, B is also radius of another drop, another bubble. So this becomes 2 by 1 the whole cube, which is 8, or 8 is to 1. Option C. The next question. A long capillary tube of radius 0.2 mm is placed vertically inside a beaker of water. The surface tension of water is 7.0 into 10 to minus 2 Newton per meter. Water rises into the capillary tube up to a height of 5 centimeter. The angle of contact between the glass and the water is. So as this question is on a long capillary, we can say H is equals to 2t cos theta upon R, rho and G. Now we require angle of contact, so we can say cos theta is equals to H or RH rho G upon 2t. So cos theta is equals to, now R is or I would say R is 0.2 mm, so it's 0.2 into 10 raised to minus 3 meters into, now H, or surface tension. H is given as 5 centimeters, so 5 into 10 raised to minus 2. Density of water is 1000 and G is 10, while surface tension is 7 into 10 raised to minus 2. So on solving we'll get cos theta as 5 upon 7. So for theta is equals to cos inverse of 5 by 7. So cos inverse of 5 by 7 is option B. The next question. The surface tension of water is 0.07 Newton per meter. Find the weight of water supported by the surface tension in a capillary tube with a radius of 0.1 meter. Now, weight is nothing but force, and force is equals to tension into length. Here, the surface tension of water is 0.07 Newton per meter. Find the weight of water supported by surface tension in a capillary tube. So, surface tension will be on both the sides, that is on all the circumference. So therefore, this will become length is equals to 2 pi r and surface tension will be 2t. Therefore, F is equals to 2t into 2 pi r, that is equals to 2 into 0.07 into 2 into 3.14 into 0.1 into 10 raised to minus 3. So that is almost 8.79 into 10 raised to minus 5, which is 88 micro Newton. Option D. The next chapter, thermal properties of matter. Question number 1. For helium, gamma is equals to 5 by 3, that is the ratio of specific heats. And for oxygen, so this is gamma H and this is gamma O, which is 7 upon 5. The values of gamma for a mixture consisting of 1 mole of each gas will be, so we need gamma equals to question mark, that is for the mixture of gases, what will be the value of gamma? Simple question. We know 1 mole, that means N1 is equals to N2 is equals to 1 mole, and gamma H is 5 by 3, gamma naught is 7 by 5, so you can use this formula N1 plus N2 upon gamma minus 1 is equals to N1 upon gamma 1 minus 1 plus N2 upon gamma 2 minus 1. So N1 plus N2, but N1 and N2 is equals to 1, so this could be therefore 2 upon gamma minus 1 is equals to 1 upon gamma 1, or gamma H is 5 upon 3 minus 1 plus 1 upon 7 upon 5 minus 1. So on simplification, I'll get 2 upon gamma minus 1 is equals to 4. Therefore, gamma minus 1 is equals to half. Therefore, gamma is equals to half plus 1, that is 3 upon 2, that is equals to 1.5. Option B. The next question. Two rectangular blocks A and B of different metals have same length and same area of cross section. They are kept in such a way that their cross sectional areas touch each other. The temperature at one end of A is 100 degrees Celsius and that of B at the other end is 0 degrees Celsius. If the radius of, or if the value of thermal conductivity is 1:3, also ratio of thermal conductivity is 1:3, then under steady state the temperature of junction will be, okay. So I would say basically if we have two rectangular metal blocks, this is A and B, one of it is at 100 degrees Celsius, the other is at 0 degrees Celsius. One end is at 100 degrees Celsius and another one is 0 degrees Celsius. Fine. So thermal conductivities of say A is K and the other one is 3K. Therefore we need temperature at the junction T. So we can say that temperature of the junction theta or T is equals to K1 T1 plus K2 T2 upon K1 plus K2. So this becomes K1 is 1 into 100 plus K2 is 3 into 0 upon K1 plus K2, that is equals to 1 plus 3. We can substitute K or 3K because in the denominator we will have K as a value, so K and K will finally cut down. So even if we don't substitute K, we can get easily the coefficient as addition powers. So it becomes 100 plus 0 upon 4. There is 100 upon 4, which is 25 degrees Celsius. A. So Wayne's constant is 2892 into 10 raised to minus 6 unit. Wayne's constant, that is small b. So small b is 2892 into 10 raised to minus 6. And the values of lambda m for moon is 14.46 microns. So lambda m for moon is 14.46 microns, that is 14.46 into 10 raised to minus 6 meters. The surface temperature of moon, so temperature has been demanded. We can use Wayne's displacement law, that is T is equals to B upon lambda max. Since lambda max is inversely proportional to T, T is inversely proportional to lambda max. Therefore T is equals to B as 2892 into 10 raised to minus 6 upon 14.46 into 10 raised to minus 6. This gets cancelled. This is directly dividing as 200. So the answer is 200 Kelvin. Option. The next question. A body cools at the rate of 3 degrees Celsius per minute and its temperature is 50 degrees Celsius. If the temperature of its surroundings is 25 degrees Celsius, then the rate of cooling of the body at 40 degrees Celsius will be. When we talk about cooling, there are two laws. One is Stephen's law, another one is Newton's law of cooling. But whenever we get temperature less than 100 degrees Celsius, yes, it relates to Newton's law of cooling. So we can say d theta by dt is equals to k theta minus theta naught. D theta by dt is given as 3 degrees Celsius per minute. K theta is 50 minus theta naught is 25. So I'll get 3 is equals to 25 K. Therefore K is equals to 3 upon 25. K is equals to 3 upon 25. Now for the second condition, d theta by dt is equals to k theta minus theta naught. If I substitute k as 3 by 25, theta is 40 minus 25. You see 40 and the temperature surrounding is still 25 degrees Celsius. So on solving this further, I'll get 1.8 degrees Celsius per minute, and that will be 45 by 25. So 1.8 degrees Celsius per minute, option D. Under the steady state, the temperature of a body is following condition: increases with time, decreases with time, does not change with time, and is same for at all the points of the body. Does not change with time, but it's different for points on the body. Okay, basically steady state is something where all the points have a constant temperature, but the value of that temperature is different. That's why we get velocity gradient, temperature gradient, that's delta theta by delta x over here. That is the rate of change of temperature with respect to distance. That means the value of temperature will be different at different points, but for a certain point the value of temperature is constant, and such a state is called a steady state. So it does not change with time but has different values at different points. That is option D. The next chapter, wave mechanics. The first MCQ: a resonance air column of length 20 cm resonates with a tuning fork of frequency 250 Hz. The speed of the sound in air has been demanded. Now, length is 20 cm and frequency has been given as 250 Hz. Now, for a resonance air column, it is an air column closed at one end. So, for pipe closed at one end, I can say N1 or N is equals to V upon 4L. So this is 250 is equals to V upon 4 into 20 into 10 raised to minus 2. On solving, we'll get V as 200 meter per second. 200 meter per second, that means the closest is 220. Option A. The next question: when an open pipe is closed from one end, then third overtone of closed pipe is higher in frequency by 150 Hz than the second overtone of open pipe. The fundamental frequency of open end pipe will be. Once again, I'll read out the question for you. When an open pipe is closed from one end, then the third overtone of a closed pipe is higher in frequency by 150 Hz than the second overtone of open pipe. The fundamental frequency of the open pipe will be. First of all, for a closed pipe, N3, that is the third overtone, is given as 7V upon 4L, and for an open pipe, second overtone will be given as 3V upon 12. So according to the condition, N3 is equals to N2 plus 150. That means 7V upon 4L is equals to 3V upon 2L plus 150. So we have 7V upon 4L minus 3V upon 2L is equals to 150. On simplification, we'll get V upon 4L is equals to 150, and fundamental frequency of pipe open at both the end is given as V upon 2L is equals to 2 into 150, that is equals to 300 Hz. 300 Hz. V upon 2L for pipe open at both the ends. This is the fundamental frequency, so we can divide 4 as 2 into 2L. So 2 will go over here, multiply with 150, and we will get 300 Hz. The next chapter, oscillation. The first question: a particle performs simple harmonic motion with amplitude A. The force constant is K. The mean kinetic energy of SHM is. Now it is performing simple harmonic motion. I can say kinetic energy is equals to half m omega square A square minus x square. So that is equal to half k a square minus x square. Now initial kinetic energy is equals to ki, that is equals to half k a square as x is equals to 0. Final kinetic energy is equals to kf, that is equals to half k into a square minus a square as x is equals to a. So therefore final kinetic energy kef is equals to 0. Now we want mean kinetic energy. So mean k is equals to initial kinetic energy plus final kinetic energy upon 2, that is equals to half k a square plus 0 upon 2, which is 1 by 4 k a square. Option B. The next question, a body executes SHM with an amplitude A. The displacement of the body when its potential energy is 1/3 of its kinetic energy. Okay, potential energy is equals to 1/3 of kinetic energy. That means half k x square is equals to 1/3 of half k a square minus x square. Half k will get cancelled. I'll get x square is equals to a square by 3 minus x square by 3. So for this is x square plus x square by 3 is equals to a square by 3. 3 plus 1 4, that is 4x square by 3 is equals to a square by 3. 3 and 3 will get cancelled. A is equals to 2x, therefore x is equals to a upon 2. B. Now we are going to do exam oriented MCQs of physics part 2, first chapter electrostatics. Now the figure shows the equipotential surface of concentric circles or concentric semicircles at O. You can see this. The magnitude of electric field at a distance r meters from O. At a distance r meters from O. Okay. The electric potential. So electric potential is given as V is equals to K Q by R. We can consider any of the surface as equipotential surface. I am considering 60 volts to be an equipotential surface. So considering 60 volt as equipotential surface. So I can say 60 is equals to KQ upon 10 into 10 raised to minus 2 as 10 centimeter as the distance given. Therefore KQ is equals to 6. Now we want electric field, so electric field is given by KQ upon R square. I have KQ as 6, so it is 6 upon R square volt per meter. 6 by R square, option D. The next question, a 4 microfarads capacitor is changed to 400 volts if its plates are joined through a resistance. The heat produced in this resistance will be. So heat produced has been demanded. We can say heat produced is given by electrical energy stored, and we can easily calculate electrical energy by half CV square. So I have C as 4 into 10 raised to minus 6 into 400 whole square. So this gives me 0.32 joules. Option B. The next question. An electron of mass m, charge E, falls through a distance h meter in a uniform electric field E, then the time of fall. Alright, so time of fall has been demanded. First of all, the force acting on an electron in electric field is E into E, that is electron into or charge into electric field intensity. Now we have force as mass into acceleration. The ma is equals to EE. Therefore, if acceleration is to be calculated, it becomes EE upon mass. Now as it is falling, you can say S is equals to ut plus half at square. S is your h, initial velocity is considered to be 0, so half a will be replaced by this term, so this is EE by m into t square. We want t, therefore this becomes t square is equals to 2hm upon EE, therefore t is equals to under root of 2hm upon EE, under root 2hm upon EE, option A. The next chapter, current electricity. In a Wheatstone's network, P is equals to 2 ohms, Q is equals to 2 ohms, R is equals to 2 ohms, and S is equals to 3 ohms. The resistance with which S is to be shunted in order that the bridge may be balanced. Okay, so we can say this entire system that is to be shunted as S dash. So S includes Sn, S dash includes S and R in parallel. So we say by Wheatstone's balancing bridge, P by Q is equals to R by S dash. So this is 2 by 2 is equals to 2 by S dash. Therefore S dash is also equals to 2. So therefore now 1 upon S dash, because these two are in parallel and effective is S dash, so 1 upon S dash is equals to 1 upon S plus 1 upon R. So this is 1 upon 2 is equals to 1 upon 3 plus 1 upon R. So therefore 1 upon R is equals to 1 by 2 minus 1 by 3, that is equals to 1 by 6. Therefore the resistance to be attached in parallel is 6 ohms. Option C. Alright. So the next problem. In a meter bridge experiment, the ratio of right cap resistance, left cap resistance to the right cap resistance is 2:3. The balance point from the left has been demanded. Alright, so 2 by 3 is equals to L upon 100 minus L. That is R1 by R2, L upon 100 minus L. So this becomes 2 into 100 minus L is equals to 3L. Therefore 200 minus 2L is equals to 3L. Therefore 5L is equals to 200. Therefore L is equals to 40 centimeter. Option C. The next problem. In a potentiometer experiment, the balancing length with the cell is 240 centimeters. On shunting the cell with a resistance of 2 ohms, the balancing length becomes 120 centimeters. The internal resistance of the cell is, okay, so we have a formula. Internal resistance of a cell is equals to R into L1 upon L2 minus 1. A simple problem. So we need to calculate R. We have resistance as 2 ohms, L1 as 240, L2 becomes 120 minus 1 is 2, 2 minus 1 is 1, so R is equals to 2 ohms. Option B. The next problem. A copper wire of length 50 centimeter and area of cross section 10 raised to minus 6 meter square carries a current of 0.5 amperes. If the resistivity of copper is 1.8 to 10 raised to minus 8 ohm meters, the electric field across the wire is. So electric field has been demanded. We can say voltage is equals to V equals to IR, and we can substitute R as OL upon A. Now electric field is given as voltage upon length, that is equals to I rho L upon AL. L and L get cancelled, comes rho I by A. Now electric field rho is 0.5, current is 0.5 into rho is 1.8 into 10 raised to minus 8, and the area has been given as 10 raised to minus 6. So on simplification this will become 0.009 volt per meter, that is voltmeter inverse, 0.009, option D. The next question. EMF and internal resistance of a cell are 1.1 and 0.5. So E is 1.1 volts and R is 0.5 ohms respectively. The EMF balances against 220 centimeter of a potentiometer wire on drawing current X from the cell. The balancing length reduces to 200 centimeters. So the L1, L2 is 200 centimeter. Then value of X has been demanded. That means current has been demanded. So I can say that E1 upon E2 is equals to L1 upon L2. So this is E1 upon E2 is equals to L1 is 220 upon 200. So we get this as 11 upon 10. Therefore E2 is equals to 10 upon 11 into E1, that is 10 upon 11 into 1.1, that is equals to 1 volts. Now E is equals to V plus X into R. Therefore X into R is equals to E minus V, and X is equals to E minus V upon R. So like here, therefore X is equals to E minus V upon R, which is equals to 1.1 as E, V is 1 upon R is 0.5. So this becomes 0.1 upon 0.5, which is 0.2 amperes. Option C. The next chapter is magnetic effect of electric current. The first question: a coil having n turns carry a current I as shown in the figure. The magnetic field intensity at a point P is. Okay, so we need magnetic intensity at a point on the axis of a coil. Now this is B is equals to mu naught Ni R square, that is radius, upon 2 into R square plus X square the whole raised to 3 by 2, which has been discussed in chapter magnetism. So it's a standard question, option A. Maximum kinetic energy of a positive ion in the cyclotron is. So maximum kinetic energy has been demanded. Kinetic energy max is equals to half mv square. Rho is equals to mv by qb is equation 1. Therefore V can be given as qb Rho upon m, If I substitute this in equation number 1, I'll get kinetic energy max as half m qb r naught upon m the whole square. So this becomes half m q square p square r naught square upon m square. Mn square you get cancel, q square p square r naught square upon 2m. So q square b square r naught square upon 2m, option C. The next question, the torque required to hold a small circular coil of 10 turns 2 into 10 raised to minus 4 meters square and carrying a current of 0.5 amperes. Current in the middle of a long solenoid of 10 raised to 3 turns per meter. That means N by L is 10 raised to 3 turns per meter carrying 3 ampere current, I1, I2, with its axis perpendicular to the axis of solenoid. Now I can say magnetic field inside the solenoid carrying current can be given as B is equals to mu naught Ni. So this is 4 pi into 10 raised to minus 7 into 10 raised to 3 into 3. Now this is 12 pi to 10 raised to minus 4 Tesla. Now torque is given as NIAB sine theta. So N is 10 into I is 0.5 into A is 2 into 10 raised to minus 4 into 12 pi into 10 raised to minus 4 and sine 90. So this is 12 pi 10 raised to minus 7 Newton meter. 12 pi into 10 raised to minus 7 Newton meter, option A. So we'll revise this sum. We say B is equals to mu naught Ni, 4 pi into 10 raised to minus 7 into 10 raised to 3. This is turns per length. So 10 raised to 3 and I that is inside the solenoid is 3. Hence we took 3 and not 0.5. Now torque due to 0.5, hence I is 0.5, N is 10, A and B respectively, and we'll get the answer 12 pi into 10 raised to minus 7 Newton meter. The next problem. A galvanometer with resistance 100 ohm is converted into an ammeter with a resistance of 0.1 ohms. Galvanometer 100 ohm and this as 0.1 ohm. The galvanometer shows full deflection with current of 100 microamperes. Then the minimum current in the circuit for full scale deflection of galvanometer will be. So Ig is being required. We can say Ig into G is equals to I minus Ig into S. We all have used this formula. Therefore, I is equals to 1 plus G by S the whole into Ig. So this is 1 plus 100 upon 0.1 into 100 into 10 raised to minus 6. So that is equals to 1001 into 100 into 10 raised to minus 6. That is equals to 100.1 to 10 raised to minus 3. That is equals to 100.1 milliamperes. So 100.1 milliamperes, option. The next question, a micrometer ammeter has a resistance of 100 ohms and a full scale range of 50 microamperes. It can be used as a voltmeter or as a higher range ammeter provided a resistance is added to it. Pick the correct range and resistance combination from the following. Okay, so let us select the first condition, that is 50 volt range, and let us calculate if the resistance comes out to be 10 kilo ohms. So R is equals to V upon Ig minus G, condition 1. So we can say this is 50 upon 50 into 10 raised to minus 6, 50 microamperes minus 100. So on simplification I'll get 10 raised to 6 minus 10 raised to 2, that is equals to 10 raised to 3 kilo ohms and not 10 kilo ohms. So this option is incorrect. So second option, so we get condition 2. I can say R is equals to V upon Ig minus G, 10 upon 50 into 10 raised to minus 6 minus 100. This is 199.9 kilo ohms, that is almost equals to 200 kilo ohms. So 200 kilo ohms for 10 volts, option B. In the next chapter, a coil carrying current I has radius R and number of turns N. It is rewound so that the radius of the new coil is R by 4. So R2 is equals to R by 4 and R1 is equals to R and it carries current I. The ratio of magnetic moment of a new coil to that of original coil is. Alright, so M1 by M2 has been demanded. First of all, M is equals to NIA, that is equals to NI into pi R square. Now M is directly proportional to NR square, therefore M1 upon M2 is equals to N1 by N2 into R1 by R2 the whole square. So therefore M1 by M2 is equals to N1 by N2 into R1 square upon R1 by 4 the whole square, that is R1 upon R1 by 4 the whole square. R1 R1 will cancel, this becomes 1 by 4 into 4 square, that is equals to 1 by 4 into 16. So this becomes 4 ones 4 fours are, so M2 is equals to M1 upon 4. So M2 upon M1 is 1 by 4, option C. The next question is, an electron in an atom revolves around the nucleus in an orbit of radius 0.24 angstrom unit. The equivalent magnetic moment if the frequency of revolution of electron is 4.8 into 10 raised to 9 megahertz. So the frequency has been given as 4.8 into 10 raised to 9 megahertz. Radius is 0.24 angstrom unit. Magnetic moment has been demanded. Frequency has been given as 4.8 and 10 raised to 9 megahertz. Now we can say magnetic moment is given as I into A. I is E upon T, that is EF into A. Now this is E is 1.6 into 10 raised to minus 19. F is 4.8 into 10 raised to 9 into 10 raised to 6 into pi r square. So this becomes 1.6 into 10 raised to minus 19 into 4.8 into 10 raised to 15 into 3.14 into 0.24 into 10 raised to minus 10. So on simplification we'll get this as 1. the whole square, 1.39 10 raised to minus 24 ampere per meter square. Option A. The next question. Magnetic field at a point on the equatorial line of a bar magnet which is at a distance r from the center of bar. Center of bar magnet at a distance r on the equatorial line. So here the distance is r and we want magnetic field, that means B. So B is given as mu naught upon 2 pi m upon r square plus l square the whole raised to 3 by 2. Here it is not 2m, it's just m because it is on the equatorial plane, hence option A. Liquid oxygen remains suspended between two poles faces of a magnet because it's the liquid oxygen remains suspended between two poles. Okay, so north and south pole, and liquid oxygen remains suspended, that means it is not attracted on either of the poles. So oxygen itself is a paramagnetic substance, hence liquid oxygen will also possess this quality of being paramagnetic. It has been equally attracted by both hands. It remains suspended and does not get attracted, so it's paramagnetic. The property possessed only by ferromagnetic substances. Option R, hysteresis, susceptibility, directional property, attracting magnetic substances. Paramagnetic substances can do this attraction, directional property, even paramagnetic substances have susceptibility, all three has. The only hysteresis is the property which only ferromagnetic substances possess. The given figure represents a material which is okay. Now we can see the lines of forces are repelled and then going there, so we can directly say that the lines of forces getting weakly repelled, so weak repulsion is observed only in only diamagnetic substances. B. We have the magnetic susceptibility of a paramagnetic substances is 1 into 10 raised to minus 5. So susceptibility is given as 10 raised to minus 5 at 27 degrees Celsius. So T1 is 27 degrees Celsius, that is equals to, or T is equals to 300 Kelvin. And at what temperature its magnetic susceptibility will be 1.5 into 10 raised to minus 5. So psi 2 I1 1.5 into 10 raised to minus 5, T2 is equals to small t2 has been demanded. Psi is inversely proportional to T. So chi1 chi2 is equals to T2 upon T1. Therefore T2 is equals to susceptibility 1 upon susceptibility 2 into T1. So 1 is 10 raised to minus 5. This is 1.5 into 10 raised to minus 5 into 300. So this becomes 300 upon 1.5. So 300 upon 1.5. On simplification, we get as minus 73 degrees Celsius as the answer. C. A charge q is circulating with constant speed v in a semicircular loop. Okay, so we have a semicircular loop over here. This center this is R, this is R. The magnetic moment of this loop is, we can say, M is equals to IA. Now we know that the charge is circulating in this loop, hence we can say that the total length the charge has to circulate is R plus R, that is 2R, plus the semicircle which is pi R, so that is R common 2 plus pi. Now time required is equals to distance covered upon velocity. So distance covered is this total length, which is R2 plus pi upon velocity. Also current is equals to Q upon T, that will be QV upon 2 plus pi into R. Now we got I, therefore I will be replaced at QV into 2 plus pi into area of semicircular loop will be pi R square upon 2. So this becomes R and square will get cancelled, QV upon 2 into pi plus 2 into pi R. So QV pi R upon 2 into pi plus 2. So pi R QV upon 2 into pi plus 2. Option B. The next chapter, EMI. In a transformer, the coefficient of mutual induction between the primary and the secondary coil is 0.2 Henry. So M is equals to 0.2 Henry when the current changes by 5 ampere per second. Okay, so current changes by 5 ampere per second in the primary, the induced EMF has been demanded. So the induced EMF, E is equals to question mark. We can say E is equals to M di by dt. So this is 0.2 into 5, which is 1.0, that is equals to 1 volts. Option B. The frequency of an alternating voltage is 50 cycles per second and its amplitude is 120 volts. Then the RMS value of voltage is, we have E as 120 volts and ERMS has been demanded. We can straight away use this formula. ERMS is equals to E naught upon root 2. So this is 120 upon 1.414, that is equals to 84.8 volts. Option B. The dimensional formula for root of LC. So we have a formula of F is equals to 1 upon 2 pi under root of LC. Therefore root of LC is equals to 1 upon 2 pi F. So frequency is in the denominator, which is per second, 1 upon second, which is equals to second. So that means L0 M0 T1 M0 L0 T1. Option A. Now the next question is, power factor is maximum in an LCR circuit. Now when in LCR circuit, in the condition of resonance, that is XL equals to XC, circuit behaves as a resistive circuit, and in resistive circuit power factor is maximum. So for resistive circuit, power is maximum, and I want it to become a resistive circle, so I'll say XL is equals to XC. Option A. The next question, in a series LCR circuit, the resistance R is equal to 10 ohm and the impedance Z is equals to 20 ohm. So I have R is equals to 10 ohms and Z is equals to 20 ohms. The phase difference between the current and the voltage, so phi is been demanded. I can say Z is equals to under root of R square plus XL minus XC the whole square. Therefore I can say Z, which is 20, is equals to the root of 10 square plus XL minus XC the whole square. On squaring both sides, this becomes 400 is equals to 100 plus XL minus XC the whole square. So this will become 300 is equals to XL minus XC the whole square. So therefore XL minus XC is equals to root of 300, is 3 into 100, which is 10 root 3. So XL minus XC is 10 root 3, and tan phi is equals to XL minus XC upon R. So this is 10 root 3 upon R is 10, 10 then you cancel. So tan phi is equals to root 3, therefore phi is equals to tan inverse of root 3, which is 60 degrees. Option C. The next question, a solenoid of an inductor has 2 henries of current and 2 henries and carries a current of 1 amperes. So what is the magnetic energy stored in a solenoid? First of all, the formula for magnetic energy is half L I square, where L is your self-inductance and I is the current. So half into 2 into 1 square. So this is 1 joule. A typical problem but an easy one. The next question, velocity of light in air is 3 into 10 raised to 8 meter per second. So we have V is equals to 3 into 10 raised to 8 meter per second, and the refractive index of water is 1.33. So mu is 1.33. The time taken by light to travel a distance of 500 meter in water. So x is equals to 500 meters. We all know that mu is equals to c by v. Therefore v is equals to c upon mu. So that is 3 into 10 raised to 8 upon 1.33. So we'll keep v as it is. Now x is equals to vt, therefore time required means t is equals to x upon v. So x into 1 upon v, so that is equals to t 500 into 1 upon v, that means 1.33 upon 3 into 10 raised to 8. So this will simplify as 2.22 into 10 raised to minus 6 seconds, that is 2.22 microseconds. Option B. Next question, a parallel beam of monochromatic light is incident on a glass slab at an angle of 60 degree. If it gives the ratio of width of beam in glass to that in air is 1.618. and the angle of refraction has been demanded. So first of all, I'll say that it is so this is AB, and if I draw tangent over here, this will give me the refracted wavefront. So this becomes CD. If this is I and this is as R, therefore AB by CD is equals to cos I upon cos R, while AC will be my common base. Now, angle of incidence has been given as 60 degree and the ratio with the beam in glass to that of air. That means it is given as CD upon AB, that is equals to cos R upon cos I. Angle of refraction has been demanded, therefore R is equals to cos inverse of cos 60 into 1.618, that is cos inverse of half into 1.618, this is 0.804. So cos inverse of 0.804, therefore R is almost equals to, now this is 0.8, which is greater than 0.5. So the angle or the theta will go on decreasing. Cos 30 is cos 30 is root 3 by 2, that is 0.866. So the value is least at cos 30. It goes on decrease, values maximum as cos 30 is goes on decreasing as we go at the higher values of theta. So it is close to 30, so it will be around 36 from the option D. The next question, a star is moving with a velocity of 100 kilometers per second. If the velocity of light is 3 into 10 raised to 8 meter per second, then the shift of its spectral line of wavelength 5700 angstrom unit due to Doppler effect. Now this is based on Doppler shift in lambda, and we can say delta lambda by lambda is equals to minus plus V by C is the formula. Taking the magnitude, we can say delta lambda by lambda is equals to V upon C. Therefore, change in wavelength, that is delta lambda, is equals to lambda into V by C. Now, lambda is given as 5700 into 10 raised to minus 10 meters into V is 100 kilometers per second. So 100 into 10 raised to 3 upon 3 into 10 raised to 8. So on simplification, I'll get this as 1.9 into 10 raised to minus 10 meters, which is 1.9 angstrom unit. Option B. Light of wavelength 5400 angstrom unit is incident on a plane reflecting surface. Its path length change will be. Now this is a simple problem. Path length change is nothing but half of your wavelength, that is half into 5400, which is 2700 angstrom unit. Option C. Hello friends, today we are going to discuss what should we do one day before CET examination. Now just one day, 24 hours, how to optimize our day, and how to cover all the subjects within this time. Now, basically, I'll deal in physics and I'll give you the proper schedule of how to study for physics on the last day and get maximum marks in the CET examination, especially how to get or how to score full marks in CET examinations. Now, first of all, physics paper, as we know the marking scheme, it is 50 marks and one question has 1 marks. So 54 seconds to solve each question. Basically, physics is made up of 2 parts, and we can attempt both the parts. Also, there will be random MCQs in the paper. The physics syllabus consists of standard 12th itself, but nowadays some of the topic of standard 11th also have been included, so I would include 11th and 12th, some important chapters. The question paper may contain 40 to 50% of easy questions, then 50 to 70% of moderate questions, and 70 to 100% of tough questions. I mean, this means up to 50%, up to 70%, and up to 100%. So that doesn't mean that 70 to 100, it means 30%, this means 20%, and this means 50%. So the paper will be most probably easier and fast as needed. The solution should be very quick. Now 50 to 7, that means 20% will be moderate questions. That means the questions from competitive examinations like Kerala CET, AIPMT, these papers, and tough questions will be from JEE mains and NEET examinations. Yes, to confirm, JEE mains and NEET examination questions will also be there in the CET examination. So that means you have to be very accurate with the answers, and you should have gone through number of MCQs in your preparation time. So what should we do one day before the examination is, first of all, optimize your hours properly. I'll be helping you with the schedule, and if you follow that, yes, surely you're going to score very good. Okay, just remember few shortcuts which are very efficient and repeatedly used in the MCQs. Now what students do, they go and start remembering all the MCQs and all these shortcuts and important formulas, but rather than we could focus on certain shortcuts, not in all the shortcuts, but certain shortcuts which have been used in all the questions, the logical and the effective shortcuts, which can give you more marks rather than learning each and every minute shortcuts. Now the problem is, if you try to learn all these shortcuts and try to remember them, it becomes very difficult because you spend more energy and time on learning those shortcuts rather than solving MCQs. So it comes like spending time on sources and not executing them, so that is not helpful. So on the final day, just try to remember important shortcuts and only learn those MCQs or those shortcuts which have been used repeatedly in the MCQs. Alright, now don't fear or worry about your weakness. Just focus on your strength. Now, what do I mean by using these 10 sentences? Now, we have been focusing on the entire syllabus of physics, but there are some topics in which we are not comfortable, or although we learned the formulas, the synopsis, yet we are not able to solve the MCQs of those chapters efficiently. That means we are not getting 100% result on those chapters. So forget those chapters on the final day. Work on your strength. Work on the chapters which you know. That will be very helpful, because that will increase your confidence, and maybe on an attempt on the tougher questions will help you in the examinations. Now, how to select chapters? Always try to select challenging chapters. Now, these chapters may be the chapters which have been frequently asked in your CET examination, the chapters which have more weightage in the CET examinations, the chapters which are easier, the chapters which are lengthy, all could be included in the challenging chapters. Try and solve multiple MCQs, and also only the useful ones. So there can be MCQs which can be very lengthy. So instead of solving those MCQs, we can by heart the answers, because CET examination they only require answer. So there are some expressions which take a lot of time to solve. So we do not have much time in the CET examinations. So what we can do, we can see those questions and by heart the answer directly, so that we can see the question and straight away mark the answer. There are some questions which have lengthy solutions and require like logbook use. So in the CET examinations we don't allow the logbooks. So what we can do, we can see the answers, we can see the question and try remember those questions and their answers, because we do not want to consume or waste time on solving long solution questions. Okay, now what is the best way to get yourself prepared for the examination of CET? You see, there are random questions in the paper. Now when you solve, you will solve in a pattern of chapter wise. You're going chapter wise. But will this help? Because going chapter wise is like monologues, and you will be learning the MCQs, you'll be learning the formulas chapter wise, and you'll be telling, yes, this is the chapter and this is the solution, this is the question. So that's not the correct way to study. What if you get a random question and you have to remember the formula at the same time? So at that point you'll get confused, and maybe you'll mix up and do a silly mistake, so that could make you lose marks. So I don't want you to lose marks. So what you can do is do mock test. It is a huge help. A mock test, you'll directly face your fear and work on your strength in such tests. Now what happens, giving mock strength prepares you for multiple questions, and also there will be time limit, so your speed will increase, and also your approach to different questions will also be improved. Now giving mock test also strengthens you with respect to understanding ability of the question paper. Now first of all, CET means, or physics paper means, if you read the question should click your mind and you should straight away go for the answer. If the question does not click your mind, that means there is a problem. So to overcome this inability, you can see multiple questions in mock test, and you can see and gather information about it. So this is how you tackle random questions in the paper and get yourself prepared for the CET examinations. Alright. Also, solving papers and learning from their solutions is very helpful. We all know that in CET examination there is a possibility of questions to get repeated. If we solve the question papers of different competitive examinations and learn from their solutions and try not to approach teachers and solve it by yourself, will be very helpful. Because when you go and solve it by yourself and you refer different questions, you'll be able to create your own shortcuts rather than depending on shortcuts from books. Shortcuts from books are helpful, but when you create your own shortcut, you will be applying that in very frequently, because that shortcut has been created by you. And if you go on applying that shortcuts, you'll become stronger and MCQs will be solved fast and quick. Now, what is the beauty of giving CET examination is, and learning is, beauty of CET and learning it is, you never forget the answer, and even if you mark it wrong, there will be no negative marking. So, not talking as a negative prospect of you marking the wrong answer, I'm just informing you about the marking scheme, that there is no negative marking, so you can go and attempt all the questions in the paper. So this is the best benefit of CET examination. And if you go on solving MCQs, you get through the answers and you remember those answers for long. So what not to do: avoid doubtful chapters. And not the entire chapter is doubtful, there are some concepts which are doubtful. See whether those concepts are asked in the examinations or not. Refer to the question papers and see which type of questions, which conceptual questions are being repeated. In our session, we have covered maximum MCQs on those concepts which teachers or the students think it's very important. Even the students find those concepts difficult. So I have tried to cover that concepts in these sessions. Also, we have gone through many CET question papers and have referred to the important and frequent chapters and the frequent concepts in the paper. So try to avoid the doubtful chapters, but see whether the concepts are doubtful or the entire chapter is doubtful. If the concepts are doubtful and if you are able to clear it, try to handle it, or not, then work on your strengths. Now, I'll give you the entire schedule of the day now. Enough of a discussion of what to do on the last day. So we'll have schedule of the day. Now basically you have 3 subjects, PCM, but my subject is physics, so I'll focus on physics and not consuming the time of chemistry and maths. I would plan my day as follows. Basically with thinking that we'll get up at morning 7 a.m. So the study in the morning is very efficient and useful. So from morning 7 to 10 a.m. what we are going to do is start revising important topics and try and remember all the important questions and synopsis. The next 1 hour, I'll allow you to take a break and make yourself relax. 11 to 1, that means 2 hours, do rigorous practice. Now 2 hours is not much, so Do rigorous practice of only competitive questions. What do you understand by competitive questions? The questions which have arrived in certain examinations, only those questions. And I know it's not feasible to cover all the chapters in these sessions, so we can do what? We can concentrate on the important chapters or whatever is your strength on those questions and those chapters. So these are the examinations, of course, the questions of which you need to solve, and only important chapters and heavy chapters. Heavy means weightage. From 1 to 2 you can take a break, that is you can do your lunch and relax a bit, and then get ready from 2 to 4, where you will be giving mock test. Yes, as I have discussed, you have to give mock test, so you'll be giving mock test and getting ready for random questions and methodology to tackle it. You can easily fight your challenge if you plan these hours properly on the last day of that examination. Now, from morning 7 to 4, you will be utilizing your day as for physics, and later on you can plan it for the other subjects also. I hope my plans and my schedule is helping you. After all, this hard work, I believe, I'm not telling I hope, I believe in you that you will surely secure full marks. All the best. Thank you.